Good morning, viewers, and a happy Janmashtami to all of my viewers. Okay, so I'm today starting with the study questions of the atomic structure question answer series. Okay, so let me start with, okay, and give the following a suitable word or phrase. Okay. The subatomic particles with negative charge and negligible mass is known as an electron. Okay. The electron, it has a negative charge and a negligible mass. Protons and neutrons present in the nucleus are known as nucleons. Okay. The electrons which are present in the outermost shell is known as valence electrons. Arrangements of electrons in the shells of an atom is electronic configuration. The number of protons which are present in the nucleus of an atom is known as atomic number. The number of the sum of the number of protons and neutrons of an atom are known as mass number. Okay. So the number of protons which are present in the nucleus of an atom, that is known as atomic number, or you can say the number of electrons which are present in the atom, they are also their number is also known as atomic number. But the mass number is the sum of the protons number and neutrons number of an atom which are present in the atom. Okay. Now, atoms of some element with same atomic number but a different mass number, they are known as isotopes. Okay. The smallest unit of an element which takes part in a chemical reaction, that is known as atom. Okay. Name three fundamental particles of an atom. Give the symbol with charge on each particle. The three fundamental particles which are present in an atom, these are electrons, protons, and neutrons. Electrons have negative charge, and that is -1, E, which has a subscript as -1 and superscript as 0. And charges -1. Proton symbol is P to the power plus, and electron has a symbol of small e to the power minus. Or you can say P, small p with the subscript of 1 as subscript, I mean +1 as subscript, and -1, also a 1 as a superscript. So the charge is positive charge +1. Neutrons, they have n, which small n is a symbol, or you can write it as n to the power 1 and subscript as 0. That is, it has no charge. The subscript represents the charge on it, and the superscript represents the mass on it. Okay. Define the following terms: atomic number, mass number, nucleons, and valence shell. Atomic number, it is the number of protons which are present in the nucleus of the atom of an element. Mass number, it is the sum of the number of protons and the number of neutrons which are present in the nucleus of the atom of an element. Okay. Then nucleons, nucleons is number of protons and neutrons, which is collectively known as nucleons. The valence shell is the outermost shell of an atom, that is known as valence shell. It is also known as valenced orbit. Excuse me. Okay. Then mention briefly the salient features of Dalton's atomic theory. One is matter consists of very small and indivisible particles known as atoms. Atoms can neither be created nor be destroyed. Third, the atoms of an element are identical in all respects, that is, in the respect of size, mass, density, chemical properties, but they differ from the atoms of the other elements. Okay, same element, the atoms are identical in all respects, but it differs from the atom of the other element. Okay, all respects means the size, the mass, the density, the chemical properties, all are same of all the atoms of the same element. Okay. Then fourth point is atoms of an element, they combine in small numbers to form molecules of that element. Of the element of an element, they combine in small numbers to form the molecules of that element. For example, say hydrogen. Hydrogen combines in small numbers. That is, two hydrogen are combining at two hydrogen atoms are combining to form a one molecule of hydrogen. Then atoms of an element combine with the atoms of another element in a simple whole number ratio to form the molecules of a compound. Okay. For example, water, they combine with in the ratio of 2:1. That is, two hydrogen atoms and one oxygen atom. So a small simple whole number ratio, they combine to form the molecule of a compound. Then atoms are the smallest units of matter that take part in the chemical reaction during which only rearrangement of atoms takes place. Okay, that means the smallest atoms are the smallest unit of matter that take part in the chemical reaction. This part of the matter that take part in the chemical reaction. That means they undergo the chemical reactions which can occur in the element, which only with the rearrangement of the atom which taking place. Okay, whether in the chemical reaction there is rearrangement of atoms, there they take part in that. Okay. Then what are the two main features of Rutherford's atomic model and state its own drawbacks? So first is, what are the two features of Rutherford's atomic model? According to this model, an atom consists mainly of two parts: centrally located nucleus, which has positive charge. Then the entire mass of an atom is calculated in it, and it is the densest part of the atom. Okay, so first is, it has an atom mainly consists of two parts. One is centrally located nucleus, which has the positive charge. Now this this nucleus, it has the entire mass of the atom, which is concentrated in it. So the nucleus contains the total mass of the atom. Okay, and it is the densest part of the atom. Okay, this is the nucleus which I'm talking about. Then the size of the nucleus also is very small compared to the size of the whole atom. Okay, now the outer, I told you there are two parts which are, according to Rutherford's model, there are two parts of this model. That is, one is the atom, the centrally located nucleus. Another one is the outer circular orbits, which contains the electrons, which revolve around the nucleus. Now, according to Rutherford, these orbits are known as shells. An atom is electrically neutral because the number of protons having the positive charge is equal to the number of electrons which has the negative charge. Okay. Now, what are the drawbacks of this model, of this Rutherford's model? So these are that it is failed. This model has failed to explain the stability of atoms. Okay, how much stable is the atom? That is this model does not explain. According to him, the charged electrons, they revolve around the atom. According to Rutherford, the charged electrons, we know they are negatively charged. Electrons are negatively charged, and they move around the circular orbits around the nucleus. Now, these, while revolving around the nucleus in circular paths, it should experience acceleration, due to which it should lose energy. Okay, as they are moving, they tend to lose their energy continuously in the form of electromagnetic radiations. As they revolve, they lose their energy in the form of electromagnetic radiations, which they give out, and they lose energy. And what happens the next, that they eventually fall into the nucleus. Okay, what that result in? This results in structural collapse of the atom. That is, the atom totally collapses because the electrons, they will come to the nucleus and fall in there. But this does not happen. What are the observations of the experiment done by Rutherford in order to determine the structure of an atom? When Rutherford bombarded a thin sheet of gold of 0.0004 centimeter thickness with alpha particles in an evacuated chamber, in an empty chamber, evacuated chamber, he made certain observations. What are those? First is, most of the alpha particles, they pass straight through the foil without any deflection from their path. Okay, the smaller fraction of them were deflected from their original path by smaller angles. Okay, most of them, they pass through the this foil. Smaller fraction, they deflected from their original path by small angles, and only few of them, they bounced back, they reflected back. On the basis of these observations, he made certain conclusions that most of the space in an atom was empty because alpha particles went straight. Okay, most of the space in an atom was empty because the alpha particles went straight. Most of them, they went straight, no, they were not deviated. So this space was empty. That's why the alpha particles could move straight. Then certain heavy positively charged masses of the atom are also there, which cause this deflection of the small fraction of the alpha particles. So some heavy positively charged mass was present in the atom, which caused this the sum of the alpha particles to deflect in by small angles. And the positively charged mass is so small, very small, and it is centrally located, and that's why few of the alpha particles, they bounced back, they reflected back. Okay, why? Because there was certain positively charged part mass, and these alpha particles are also positively charged. So some of them, they as this charges are same, no, so they deviate. I mean, so they reflected back. Okay, and this they named as, it was named as the nucleus of an atom. This central portion, which has the mass, okay, and contained the positive charge, this was named as the nucleus. Okay. Next is, state the mass number, atomic number of neutrons, mass number, atomic number, number of neutrons, and electronic configuration of the following atoms. First, C 12 by 6, 12 and 6. So it is the 12, which is written upper, that is as superscript. That is the mass number. Atomic number is 6. Neutrons is also 6, because atomic number is means that either it is a number of protons or number of electrons. So mass number is 12. So mass number minus atomic number, that is equal to the number of neutrons. So it's 6. The electronic configuration is 2 and 4. Atomic diagram is this. First shell contains 2 electrons, and the second cell, the valence shell, contains 4 electrons. Then O 16, 8, and that is mass number 16, atomic number 8, neutrons 8. Same way, neutrons is equal to atomic mass number minus atomic number. Then electronic configuration 2, 6, that is 2 electrons in the first shell, and second shell contains 6 electrons. Okay. Then we come to fluorine F, which is 19 and 9. That means mass number is 19, atomic number 9, neutrons 10. Electronic configuration is 2, 7, 2 and 7. Though that means 2 on the first cell, and in the second cell there are 7 electrons. Then neon, Ne, that is mass number is 20, atomic number 10, neutrons 10, 2 and 8. That means 2 electrons in the first shell, second shell 8 electrons. Okay. Then aluminium 27 as the mass number, and atomic number is 13, neutrons is 14, 2, 8 and 3. So it will be 2 electrons in the first cell, second cell 8, and third cell is 3 electrons. Okay. Next is Cl, chlorine, that is 35 and 17. So 35 will be the mass number, atomic number 17. Neutrons will be 8. So 2, 8 and 7. So first shell 2, second shell 8, third shell is 7. Okay. Now, what is the variable valency? Next question. Name two elements having variable valency and state their valencies. Some elements exhibit more than one valency. They are said to have variable valencies. Okay, so some elements, they have certain they exhibit certain valencies which is more than one. Okay, then they are said to be having variable valencies. For example, iron and copper. Iron has +2 and +3 valencies. That is, +2 is named as ferrous or Fe2 in Roman numbers 2. +3 is named as ferric or Fe3. Okay, and copper has +1 and +2 valencies. So +1 is for cuprous or Cu1. Then +2 is cupric or Cu2. Okay, so these elements, they exhibit variable valencies. Okay, there are certain non-metals also which exhibit variable valencies. The atomic number or the mass number of sodium are 11 and 23. Okay, atomic number and mass number. So atomic number is 11, mass number is 23. What information is conveyed by this statement? So atomic number is 11 and mass number is 23, we know from the question. Now that means number of protons is 11, number of electrons is 11, number of neutrons is mass number minus atomic number, that's 12. Electronic configuration is 2, 8, and 1. Therefore, valency is equal to 1. This much information we get from this question. Now explain the rule with example according to which electrons are filled in the various energy levels. The first rule, the maximum number of electrons in each cell or orbit is determined by the formula 2n square, where n is the number of shell. So first rule is the maximum number of electrons which is present in each cell or orbit, that can be determined by the formula 2n square. 2 into n is the number of shell, that is first, second, third, fourth, like that, and n square. That means if it is in the first cell, K shell, that is, then the number of electrons will be 2 into 1 square. First shell, so 1 square, that is 2 into 1, that is equal to 2. So number of electrons will be 2. L shell, if it is, then 2 into 2 square, that is second shell, no, that is 2 square. Therefore, 2 into 4, that is 4 to the 8. M shell, if it is third shell, so 2 into 3 square, that becomes 18. N shell, fourth shell, so 4 square, that is 32. Like this, it goes on. For example, calcium, which has an atomic number as 20 and mass number as 40. So number of electrons will be 20. Okay, so K shell will be 2 into 1 square. Then L shell will be 8. The M shell will be 18, but it has, as according to the rule, it is 18, but it has 10 electrons remaining. So the maximum number will be 8 here. Okay, it has 10 electrons remaining. It does not have more than 10 in the last shell. So in the third shells, not last cell, in the third shell. So it cannot be 18. Okay, because then it will contain 8 in the third shell, and the last 2 electrons will pass on to the last valence shell. Okay, the N shell, which should contain 32 electrons, but according to the rule, that is 2 into 4 square, 32 electrons, but it has only 2 electrons left. So that will be in the N shell, and N shell will become its valence shell, calcium valence cell. This happens according to the octet rule. Okay, this happens according to the octet rule. That means the outermost orbit cannot have more than 8 electrons. Okay, the outermost orbit cannot have 8 electrons according to octet rule. Now, second rule is electrons are not accommodated in a given shell unless the inner shell are filled. Unless the inner shells are filled, you cannot accommodate, you cannot go to the next shell. That is, the shells are filled in a stepwise manner. The electrons cannot fill like first, then third, then fourth, not in a haphazard way. It should fill up in first, then second, then third in order. Okay. Then next question. The atom of an element is made up of 4 protons, 5 neutrons, and 4 electrons. What is its atomic number? So as it has 4 and mass number, so as it has 4 and protons and 4 electrons, so the atomic number will be 4 and mass number will be, as it has 4 and protons and 5 neutrons, so mass number will be 4 plus 5, that's equal to 9. Okay. What are the 2 main parts of which an atom is made up of? It is made up of, one is nucleus and the orbits or the shells which are present in the empty space surrounding the nucleus, which has the electrons. Then what is the nucleus of an atom? Where is the nucleus of an atom situated? It is present in the center of the atom, at the center of the atom. And what are the orbits of the shells of an atom? They are imaginary parts which are traced by the electrons in the empty space surrounding the nucleus. Each orbit is associated with a fixed amount of energy, and therefore the circular orbits are known as, they are also known as energy levels or energy shells. Okay. So what are isotopes and how does the existence of isotopes contradict Dalton's atomic theory? Now, isotopes are the atoms of the some elements with the same atomic number but a different mass number due to the difference in the number of neutrons in their nucleus. Okay. Atomic number is same, electronic configuration is same, but only difference is their mass number, because neutrons which are present in the nucleus, that differs between 2 atoms of an element, of the same element. Now this contradicts the Dalton's atomic theory. Dalton told that the atoms of the same element, they do not differ. But here we see that atoms of the same element, they differs. The existence of isotopes proved that his theory was not fully correct. According to the latest researches, there are certain drawbacks in this theory. Atoms are not indivisible. He told atoms were divisible. Okay, according to him, atoms were indivisible, but they cannot be divided further. But they can be divided into electrons, protons, and neutrons. Then atoms, every atom of an element is not identical. He told the atoms of an element are identical, but isotopes prove that these atoms of the same element, they are not identical sometimes, because they have different mass numbers. That is, presence of neutrons is number of neutrons that differs. So I think I'll stop here. I'll continue with the rest of the question answers in my next video. Please go through this. If you have any doubt, please do write in the comment box, and do share with your friends so that they can also be benefited from these videos, and do subscribe to get the notification of my next video. And you can also, if you have any doubt, you can also refer to my email ID kasturi74@gmail.com. Okay. Please, you can write it. You can always write in the email box. Okay. I'll be there. Okay, I'll reply you as soon as possible. Okay, whatever doubts you have, you do discuss with me. Okay. And thank you for watching, and have a good day, and do celebrate very nicely the happy Janmashtami. Okay, thank you for watching. Have a good day.